Good day to everyone. I'm Junelle Gonzales, and together with Samina Gurung, Thao Tran, and Rajan Patel, we will discuss about reliability of wearable sensors to detect agitation in patients with dementia. Prospectively, this wearable sensor prototype aims to recognize or initially focus on the detection of agitation in patients through a software that utilizes four sensors, namely triaxial accelerometer for limb movement, heart rate monitor, microphone for the audio and pitch analysis, and lastly, Bluetooth for location tracking. For our group's motivation, let us define first what is dementia. Dementia is a general term for memory loss, which can be a common symptom for many neurological diseases. It is often characterized by behavioral changes, and some figures are not always known, which can be a safety concern for their family, care providers, and the community as well. That's why it is very important to catch agitation early for that, so that we can guide the care providers how to make their work easier. And we will now proceed to the next slides for further discussion.
The problem we are addressing is detecting agitation in individual dementia using sensors. Agitation is a complex and multifaceted behavioral symptom that can manifest in various ways such as verbal aggressions, physical restlessness, or pacing. The key challenges in detecting agitations using sensors are variability in agitation's presentation. Everyone shows agitation differently, making it difficult to develop a universal detection system. Noisy environment like background noise can interfere with different capture, leading to false positive or false negatives. People with dementia can respond dissimilarly to the same stimuli, making it challenging to develop a one-size-fits-all solution. These challenges highlight the need for a personalized and adaptive approach to detecting agitations in individuals with dementia. By understanding these challenges, we can develop more effective solutions that improves the care and quality of life with individuals with dementia. Thank you.
Hello everyone, my name is Thao and today I will tell you guys about the datasets and features. We collected data from 8 people living with dementia. All of them shows like behaviors and psychological symptoms known as BPSD. To trust their behavior, nursing students observe each person and use an iPhone app to recall what they saw, which using contains menstrual agitations inventory, CMAI. This is a standard tool used to measure agitations in older adults. Mm, at the same time, a group of computer science students have this by labeling when espresso of agitations occurs. Mm, this gave us both medical and technical perspective on what were happening. Mm, Data was collected over 2 days, allowed to get snapshot of both behavior and physical change during that time. Um, with you a mix of wearable device and smartphones to gather the data. For wearables, we use it to track heart rate and body movements. And for smartphones, we use that one to capture sounds from environment and use Bluetooth to detect the person's locations. Um, this setup helps us understand not just what the persons were doing, but also where they were and how their body were reacting. The device used to detect the behavior change in patients are accelerometer for movement, heart rate monitor for heart rate, and visual microphone to pick up voice and noise. And for Bluetooth, we use that to track locations and movement in patients. We choose these tools because they are easy to use, affordable, and widely available. What? Because smartphones and smartwatches are common and don't require complicated setups. That makes this approach practical, not just for research, but also for real-world care settings like nursing homes or home care where early detections of agitations can really help improve the quality of life.
Hello, this is Samina Gurung. Today I'm going to talk about the outcomes of the wearable sensor used to detect and record the behavior changes in the individual with dementia. As we explore the methods and device use, let us learn how well it performs in practice. Overall, the movement data collected by the device closely aligned with direct human observation, suggesting the sensor is effective in detecting the physical indicator of agitation. Heart rate and voice data provided some additional insights, although the usefulness varied based on the situation. The audio component of the device showed limitation. In high noise environments such as care homes, the audio often was unclear, reducing its reliability for detecting the physical and verbal signs of distress. In conclusion, the study identified several key insights. Firstly, wearable technology demonstrates significant potential in detecting the early signs of agitation, particularly related to physical changes such as movement and heart rate. However, the audio detection capability require further development. Maybe it will be effective in quieter places like private home. Additionally, the findings highlight the need for further testing with larger and more diverse population to validate the effectiveness of this technology with other different user groups. Importantly, the main focus was on the individual with dementia. However, this technology offers promise for the use for other vulnerable population, which includes people with brain injuries, autism spectrum disorder, and other special needs. Thank you.
Thank you for watching.
See you.